So now let's talk about high availability. What is that? Why is it important for enterprise application and how to use it? First of all, just to understand what is that the high availability term means, let's try to imagine the following situation. For example, we have few customers. Let's just call them customer 1, customer 2, and customer 3. And imagine that we have our service, somewhere in our data center. So let it be data center. And that service, let it be service 1, service number 1. It has an open or exposed API to that from the data center. So service also connected to the database where it stores some data, and actually during the request which it gets from, let's say, customer 1, it retrieves the data from the database and return it back as a response. Okay, that's good. Now, very important criteria. Our service has a physical measurement which we can call through output, and let's imagine that through output for the service. So through output for the service S1 would be, well, let it be 1000 requests per second. That means that service can serve at the same time simultaneously only 1000 requests. All the rest it pushes into the queue. Let's remember what queue is that. Queue is the simple structure where our requests, so let it be request 0, and here would be request n and request 1. They are stored in that queue in case the through output is for the service is reached its maximum. So in that case it means, well, there will be 1000 parallel requests or channels, and each of them probably may have the queue where actually any of these requests will be stored. So as far as you know, queue has a principle FIFO, first in, first out, which means that if the RN request would be the first who came in, then it would be the first serve by this service 1. Okay, so that's the initial data, and right now let's start it in action. Imagine that customer 1 sends, let's say, 500 requests per second. So it used such a through output. Our customer 2 also send, let's say, 400 requests per second to our service. So it means that our service is very, very close to its maximum through output, and soon it will be limited. So the customer 3 at the same time, well, just to get served, is allowed to send, let's say, 100 requests per second only. However, imagine that customer 3 is the biggest one, and it's not sending not 100, but let's say it sends 700 requests per second. So definitely at this time we will have a queue of the requests, and our service start serving those requests in order they came into the queue. That's okay, that's a normal situation. However, each request has its own time to leave. Let's call it TTL 0 and TTL 1 in this case. And imagine that the time to leave for request 1, for request 0 is different than for request n. For example, well, here it could be 30 seconds, and here for request 0 it could be, well, let it be 10 seconds. Oh, sorry, no, not 10 seconds, 1 minute. In this case, well, this request still would be served, but imagine that we have a synchronous communication where this request during its maintenance by the service 1 simply block the service. And that means that, for example, when we can just try to draw it like a diagram here. This means when, let's say, this request n came here and start serving at this point, nothing will be happen until actually the service finish serving that request. So this time would be blocked. And no, from these queue, I mean nothing will be served as well. So eventually, if you just start summarizing these data, these numbers, you will see that some of the requests start dropping off because service 1 physically cannot serve them. And that means that any of these customers start getting errors because the service wouldn't provide correct data. Instead, it will return exceptions, well, generally it could be timeout exceptions, but it could be something different depending on our service, which is not good for our customers. And again, they just try to resend again that requests, and at the same time they just enlarging the queue more and more, and eventually, well, it could lead to denial of service attack. Well, a kind of denial of service attack. At least that's a classical picture of a DDoS attack. What can we do? And how high availability can serve and can help us to resolve this issue? Well, the very easiest way is just to create another instance of the service. So let's call it service 1A, sorry, that's a service number 1A. And let's create another instance which we can call service number 1B. So now, and yes, let's connect their own databases to these services, to these instances. And now, all we have to do is just to use any kind of API gateway. So let it call API gateway. And a load balancer inside this API gateway, which simply start sorting in all incoming requests into that service 1, then to service 1A, then to service 1B. And in this way, it means we provided high availability of our service by multiplying instances for that service to the final customers. And customers will hopefully never get any kind of exception or errors or anything else, because all of their requests would be served by this service, by many instances of this service. And that's what high availability means.